Welcome to the deep dive. Today we're tackling something that seems incredibly basic, counting, but it turns out how young children learn to count is surprisingly complex.
Absolutely. It's not just saying numbers by rote.
Exactly.
Yeah.
It's this whole journey from a toddler reciting numbers to, well, a child actually understanding quantity. And it's packed with these fascinating twists. We're going to explore that, diving into some really eye-opening research from educational psychology. Hopefully give you a few of those aha moments.
That's right. We're focusing on a really important piece of work, Robert Siegler's 1991 article, In Young Children's Counting, Procedures Precede Principles. And like you said, this isn't just a snapshot. It's looking back at a whole decade of investigation into how this really fundamental skill develops.
You're right. And for you listening, our mission today is to really dig deep. We want to unravel the relationship between learning how to count, the steps, saying the numbers in order, pointing and grasping the why behind it, the actual
The
concept.
meaning of the numbers.
Yeah.
Yeah.
The big question Siegler tackles is which comes first?
And what's interesting right from the start is that Siegler finds some common ground. He actually agrees with Elbers that knowing when to use a procedure, like counting, is just as vital as knowing how to do it or understanding the concepts underneath.
That's a great point. Like those physics students you hear about.
Exactly. They can rattle off formulas, but they haven't got a clue when to actually apply them to solve a real problem. That when is absolutely critical.
It's not just the mechanics. And Siegler also acknowledges, importantly, the influence of social context, right?
Definitely. He notes its significant role. Culture, interactions with parents, teachers, peers, these all shape how kids learn and think.
Okay, so that's the groundwork. Now let's get into the heart of the debate.
Okay, let's unpack this.
Yeah.
The central disagreement, really, has been whether a child's grasp of counting principles, the fundamental ideas, comes before or after their ability to actually do the counting, the procedure.
And principles means things like,
Like cardinality, knowing the last number you say is the total amount, and ordinality, understanding the sequence, that numbers come in a fixed order.
right. So one camp, Gelman and Gallistel, they argued that this understanding, these principles, they form the foundation, right? That kids kind of know what counting is for, and that guides how they learn the steps.
Precisely. Their idea is that children have this inherent sense of, say, one-to-one correspondence. Each object gets one number. Or the stable order principle, you always say 1, 2, 3, not 1, 3, 2. They argue this conceptual grasp comes first.
It enables the skill.
Yeah. But then you have Siegler, based on his research, particularly with Diane Bryars, arguing pretty much the opposite. Their work suggests the procedural knowledge actually doing the counting develops before the child fully understands those underlying principles.
Which feels a bit backwards, doesn't it? You'd think you need to understand something before you can do it properly.
It does seem that way intuitively. But Siegler's argument gets really compelling when you look at the data, especially from 3-year-olds in the Bryars and Siegler study. And this is key because, as Siegler points out, Elber's review of this work, surprisingly, skipped over the findings from this specific age group.
Wow, okay. That seems like a big omission. So what did these 3-year-olds do? What was so crucial?
Well, they show this really interesting kind of mixed pattern. They were generally good at spotting when a standard correct count was, correct.
Okay, makes sense.
And they often correctly identified counts with obvious errors, like skipping an object. And here's where it gets really interesting. They often incorrectly labeled counts that were unconventional but still technically correct as being wrong.
Unconventional how? Like counting backwards or something?
Or maybe counting from right to left instead of left to right, or pointing unusually but still hitting every object once. Even if the final count was accurate, they'd often say, nope, that's wrong.
Huh. So they reject a perfectly good method just because it's not the standard way. That's a bit of a head scratcher.
It is. But even more striking was that these same 3-year-olds frequently judged counts that were actually erroneous, like double counting an item as being correct.
Wait, so they reject correct but weird counts, but they accept clearly wrong counts.
Exactly. They might see someone count 3 objects as 1, 2, 4 and say, yep, that's right.
Okay, wow. So how does that square with the idea that social context is the main driver, Elber's view?
Well, that's Siegler's challenge. He argues that a purely social context explanation, like kids just imitating what they see, might maybe explain one of those things.
Yeah.
Perhaps they reject weird counts because they've only seen the standard way.
Okay.
Or maybe they accept errors because they haven't learned to spot them reliably yet. But it's really hard for that social context idea to explain both things happening in the same kids, rejecting correct but weird counts and accepting incorrect counts. It kind of pulls the theory in opposite directions.
Yeah, that makes sense. It's like social rules would have to be incredibly specific and contradictory. What about the Scruffy the puppet argument? That often comes up in relation to social context, doesn't it?
It does. The argument was that the way the puppet Scruffy was introduced might have biased the kids. The instructions mentioned Scruffy knows his numbers, but sometimes makes mistakes. Some critics suggested this phrasing might make kids doubt their own judgment if they disagreed with Scruffy.
Ah, so the kids might think, well, Scruffy knows numbers. Maybe I'm wrong if I think he messed up.
That was the concern. But Siegler pushes back by quoting the actual instructions used. Things like, Scruffy is just learning to count. Sometimes when he counts, he makes mistakes. And crucially, watch him very carefully to see if he makes a mistake.
That doesn't sound like they're setting Scruffy up as an infallible expert at all.
Not really. It sounds more like they're asking the child to be the judge to help Scruffy. And Siegler points to another experiment they did to test this social influence idea more directly.
Oh, what do they do?
They had 3-year-olds watch an adult model correctly, judging Scruffy's counting, identifying both his correct counts and his mistakes. The adult was even praised for being right. So a very clear social cue about correct judgment.
Okay, so they showed the kids exactly how to judge correctly. Did that help the 3-year-olds get better at judging Scruffy themselves?
Surprisingly, no. It had no significant impact. The 3-year-olds' accuracy in judging the puppet stayed pretty much the same, whether they saw the adult model or not.
Wow, so even explicit social instruction didn't change their underlying performance. That really does challenge the idea that social context is the sole explanation here.
It certainly weakens it considerably. So, if it's not just social learning, what was the main takeaway from Briers and Siegler?
What's the big finding?
The absolute core finding, the one Siegler really hammers home, is that these 3-year-olds were significantly better at actually doing the counting procedure themselves than they were at judging whether someone else's count was correct based on the principles.
So, better at the how than understanding the why behind judging others.
Precisely. To give you the numbers again from that second experiment, 9 out of 16 kids could count correctly themselves on at least 75% of tries. But none of those kids could accurately judge the puppet on that many trials. And crucially, no children showed the opposite pattern: good at judging, bad at counting.
Okay, that's pretty stark. The ability to do it came first. That really flies in the face of the principle first idea from Gelman and Gallistal.
It really does. And Siegler notes, thankfully, this wasn't just some isolated finding from his lab. Other researchers, using different methods, started finding similar things around the same time.
Ah, good old replication and independent verification. Who else was looking into this?
Well, Fry and his colleagues over at Cambridge University used a slightly different setup. Instead of a puppet, they had kids watch an adult experimenter count and state the total, the cardinality. And the experimenters sometimes made errors on purpose.
Okay.
And they also played with the social cues, having the experimenter say things like, I think I counted right, have I? Trying to see if kids would just agree because the adult seemed unsure.
Ah, clever. Testing if they'd just defer to the adult. What happened?
Well, first, kids often accepted counts with clear errors, just like in the Scruffy studies. But importantly, those social cues, the experimenter acting unsure, had basically no effect. Kids were just as likely to call out a mistake whether the adult seemed confident or hesitant.
So they weren't just being agreeable, they were making their own judgment, even if it wasn't always accurate yet.
Exactly. It strongly suggested they were using their own understanding, limited as it might be, rather than just following social leads. And Fry's conclusion, similar to Siegler's, children needed to be able to count pretty well themselves before they could reliably judge someone else's counting. Procedure before principle again.
Okay, so that's converging evidence. And you mentioned Wynne at MIT used a totally different approach.
Yes, Karen Wynne took a more observational route. She watched young kids, often around 2.5 to 3.5, in situations where they had to use counting, like being asked to give Big Bird a specific number of toys.
Like, give Big Bird 5 blocks.
Exactly. And her findings were really quite striking. She found many children, especially before about 3.5, behaved in ways that directly violated the cardinality principle, the idea that the last number word tells you the total quantity.
How so? What did that look like?
Well, a classic example she gives is a child asked for, say, 6 objects. They might only grab 3, but then when asked to count them to check, they'll point to the 3 objects and say, 1, 2, 3, that's 6.
Whoa. So the act of saying six at the end somehow makes it six in their mind, even though there are only three.
It seems that way. It's like the final number word in the sequence they know takes precedence over the actual quantity they just counted.
Hmm.
Wynne also noted some kids follow a kind of cardinality rule. They know to repeat the last number word if asked how many, but they don't connect it to the set's actual numerosity.
So they might count one, two, three, and if you ask how many, they'll say three, but they don't necessarily grasp that three represents the entire group they just counted.
Right. Or worse, they might even adjust their counting sequence to hit a target number. Asked for 5, with only 2 objects, they might count 1, 5.
Goodness. It sounds almost like counting is just a verbal routine at that early stage, like reciting a rhyme.
That's very much Wynn's conclusion. She described early counting as potentially starting as a meaningless activity, similar to patty cake or singing the alphabet. The understanding of the principles, the meaning, she argues, is gradually abstracted from doing the procedure over and over.
Yeah.
Kids can count accurately before they fully get what that final number word signifies about the quantity.
So putting it all together, Siegler, Fry, Wynne, different methods,
Different labs, yeah.
they all seem to point to the same conclusion. Kids learn the how of counting before they fully grasped the why. The procedure precedes the principle.
Exactly. And Siegler makes the point that this convergence, this consistent finding across different studies, makes it really difficult to just explain away as an artifact of social context or specific experimental setups. It seems pretty robust.
Okay, so if we accept that procedure generally comes before principle, the big question becomes, how does that shift happen? How do kids go from just doing the steps to actually understanding the concept? Siegler must have some thoughts on modeling this.
He does. He outlines what a successful model would need to explain. It needs to account for several key facts we know. First, even tiny infants show some basic grasp of quantity for very small sets, like distinguishing 2 dots from 3.
Right, the subitizing idea.
Yeah, that innate number sense. Then, by around 18 months or so, maybe earlier, they start showing basic ordinality, like knowing more or less. Then fast forward to 2.5 or 3 years old, and they get pretty good at accurately counting small or medium sets.
Okay, so those are the building blocks.
Right, but then, as we've seen, that counting skill seems initially disconnected from a solid understanding of cardinality or ordinality, and then you get that weird phase, maybe 2.5 to 4.5 years old, where they accept principal violations but reject unconventional correct counts.
That messy middle ground.
Exactly. And alongside that, they slowly get better at spotting actual errors. The range of things they accept as correct narrows down. So how does the model explain bridging that gap?
Yeah, how do they get from reciting to understanding?
Siegler proposes that experience with the counting procedure itself is key. Trying it out, making mistakes, maybe even deliberately counting in funny ways, this gives them data. It helps them implicitly figure out which parts of the procedure are essential, like hitting each object once, and which are just stylistic, like counting left to right.
So trial and error helps them sort the rules from the fluff.
That's a good way to put it. He also suggests that the child's growing understanding of cardinality for those small staple sets, knowing 3 is always 3, starts to act as a check. If they count their 3 blocks and get 4, they might start thinking, something's wrong with how I counted.
Ah, so their basic quantity sense becomes a way to validate or invalidate their counting procedure.
Right. And there's another piece, automatization. As counting becomes more automatic, less effortful.
Like learning to drive, you stop thinking about the clutch.
Exactly. It frees up mental bandwidth. This allows kids to notice inconsistencies between what they know about quantity, for small sets, and the results they're getting from counting. They have more resources to think about the meaning.
So getting good at the how actually frees them up to figure out the why.
That seems to be the core idea. And Siegler wraps up by suggesting this whole dynamic procedure-informing principle, which then refines procedure, might not just be about counting. It could be a fundamental pattern in cognitive development generally.
Okay, let's try and synthesize this for everyone listening. The big takeaway seems to be that counterintuitively, perhaps, young children often learn how to perform the actions of counting, saying the numbers, pointing before they truly develop a deep conceptual understanding of why it works, what those numbers actually mean in terms of quantity.
Yeah, the skill comes first, the deep understanding follows. It definitely challenges that intuitive notion that you must understand something fully before you can do it.
Absolutely. Which leaves us with a final thought for you, the listener. If something as basic as learning to count seems to work this way, procedure first, principle later, what might that tell us about how we learn more complex things throughout our lives?
Could focusing on the how, on practicing the procedure, actually be a necessary first step sometimes, even before we fully grasp the underlying theory or the why?
It's definitely something to ponder regarding your own learning. Maybe sometimes you just need to dive in and do it to eventually understand it.
We really hope this deep dive has given you a useful shortcut into this fascinating corner of child development and maybe spark some insights into learning itself.
Thanks for joining us on the deep dive. Until next time, keep exploring.